Balancing redox reactions is seemingly really strange. I'm going to write out a list of processes, and the list of processes, if you just follow it, it works, but we need to talk about what each step means as we go. I'm going to write the steps down right now. You might want to fast forward through it, or you can write as I write. Okay, so step one is going to be to split the reaction into half reactions. Step two is we're going to balance each half reaction. I should say here that these are being balanced in acid. You generally are told whether it's an acidic or basic environment. Okay, I'm going to balance each half reaction. To do that, I'm going to balance elements other than hydrogen and oxygen. Then we add water to balance oxygen. Add H plus. To balance hydrogen. I'm going to leave a space here between C and D, because when it's in base instead of acid, there's one step we're going to add in there. Okay. And then we add electrons to balance charge. Then step three, after we've done that for each half reaction, we make sure the number of electrons in each half reaction is the same, so that they will cancel out. They should be on the product side of one and the reactant side of the other. Then we recombine, cancel, and check. Okay, keep these steps handy. I'll be scrolling back up to them, and we'll go through an example in just a second. Okay, I wrote out a practice problem here. Fe plus 2 plus permanganate is going to combine to make Fe plus 3 Mn plus 2. All right, I'm going to split into half reactions. I'm going to do the iron one first. So to do half reactions, you pick the things that mostly look alike. I'm going to write Fe2 plus becomes Fe3 plus. Looking through, balance each half reaction. I'm going to balance elements other than hydrogen and oxygen. In this case, it would mean the irons, and they are balanced. And then add water to balance oxygen, add hydrogen to balance, or add H plus to balance hydrogen, irrelevant in this half reaction. Add electrons to balance charge. So what I do is I add up the total charge on each side of the reaction. So here my total charge is plus 2. Here my total charge is plus 3. Electrons are negative, so whatever side I add them to is going to bring that charge down. So if I add an electron here, that changes my total from plus 3 to plus 2, and now they match on each side. Okay, let's take a look at my permanganate half reaction. I have MnO4 minus going to Mn plus 2. This one's going to be more work than the previous one. Okay, balance elements other than hydrogen and oxygen. Manganese is balanced. Add water to balance oxygen. I have 4 oxygens on the left-hand side, so I'm going to add 4 waters to the right-hand side, and now we have the same number of oxygens. Step C, add H plus to balance hydrogen. I have 8 hydrogens on the right, so I'm going to add 8 H pluses to the left. Next, add electrons to balance charge. My total charge on the left-hand side, -1 plus 8 times +1, is +7. 7. 7. 7. 7. 7. 7. 7. 7. 7. 7. 7. 7. 7. 7. 7. 7. 7. 7. 7. 7. 7. 7. 7. 7. 7. 7. 7. 7. 7. 7. 7. 7. 7. 7. 7. 7. 7. 7. 7. 7. 7. 7. 7. 7. 7. 7. 7. 7. 7. 7. 7. 7. 7. 7. 7. 7. 7. 7. 7. 7. 7. 7. 7. 7. 7. 7. 7. 7. 7. 7. 7. 7. 7. 7. 7. 7. 7. 7. 7. 7. 7. 7. 7. 7. 7. 7. 7. 7. 7. 7. 7. 7. 7. 7. 7. 7. 7. 7. 7. 7. 7. 7. 7. 7. 7. 7. 7. 7. 7. 7. 7. 7. 7. 7. 7. 7. 7. 7. 7. 7. 7. 7. 7. 7. 7. 7. 7 My total charge on the right is +2. So I'm going to need to add electrons to the left-hand side in order to bring the charge of 7 down to 2. How many electrons do I want to add? 5 electrons. Now I'm ready to make sure the number of electrons in each half reaction is the same so that when I put them back together, the electrons will cancel. I have 5 electrons in this reaction and only 1 electron in this reaction. The way I make it so that it's equal is I multiply this entire reaction by 5, giving me 5 Fe plus 2 plus 10 electrons. Now I can recombine them. Everything that's on the left-hand side, I'm going to put on the left-hand side of the arrow. MnO4 minus plus 8H plus 5 Fe2 plus. If I want, I can put the electrons and then cancel them, or I can know that they're going to cancel. Oh, correction up here. That should have been a 5, not a 10. Now my products, I have 5 Fe plus 3 plus 5 electrons plus Mn plus 2 plus 4 waters. I cancel anything that appears in the same form on each side of the equation. In this reaction, that's just the electrons. Sometimes it's some of the H pluses or some of the waters. So now rewriting the reaction. The way I check my work is I add up the total charge on each side of the reaction to see if it's the same. So manganese is -1. I have 8 hydrogens, and then 5 times 2, I have 10 from that. So my total left-hand side is +17. For the Fe's, I have 5 +3s. And then I have a +2 from the manganese, and the waters are neutral. So I have +17 on the right, and that checks out. And this is my answer to this problem. I'm going to ask you to try one, and then I'll go through the solution to that. For this one, I recommend stepping through it with me. So step 1, split it into the half reactions. Pause the video, split, and then check your answer. Those are my 2 half reactions. Now we're going to balance each half reaction. If you want to pause and try it yourself and then come back and check your work, that's a great idea. I'm going to balance the iodate reaction first. You can balance whichever one you want. I'm going to balance elements other than hydrogen and oxygen first. Now I need to add water to balance the oxygens, and I need to add hydrogen ions to balance hydrogen. Now I'm going to add electrons to balance. I'm going to rewrite this first just because it's a little messy. Okay, so to balance charge, on the left-hand side of the reaction here, we've got a total of +10. On the right, we have a total of 0, so I'm going to add 10 electrons to the left-hand side. Okay, for my hydrogen peroxide half reaction, I have nothing other than hydrogen and oxygen. I don't need to add water to balance oxygen because oxygen's already balanced. I do need to add hydrogen ions to balance charge. And I need to add, I need to add hydrogen ions to balance hydrogen. Now I need to add electrons to balance charge. So this side is going to get 2 electrons so that both sides have a charge of 0. So rewriting this half reaction, H2O2 becomes O2 plus 2H plus 2 electrons. Now I'm to the point where the next step is to make sure I have the same total number of electrons in each half reaction. I have 10 on the first reaction, 2 on the second reaction. So I'm going to need to multiply this whole reaction by 5. So I take this 5 and distribute it through. Now I'm ready to recombine reactions and then I can cancel. So I'm going to take all of my products, all of my reactants and put them on the left, but I know that the electrons are going to cancel. So I'm just going to cancel them now. This should have been 10 electrons. So for my left side, 2IO3 minus plus 12H plus 5 hydrogen peroxides. For my right-hand side, I have I2 plus 6 waters plus 5 O2 plus 10 H pluses. I can still cancel more stuff. Do you see how I have 12 hydrogens on the left and 10 hydrogens on the right? I can cancel 10 of those. And so this will become just 2 hydrogens that are left. Now I'm going to rewrite my answer. And then I'm going to check the charges. Okay. On the left here, iodates are -1. I have 2 of them. I have 2 hydrogen ions, which are +1s. The hydrogen peroxide is uncharged. My total on the left is 0. My total on the right is 0. This is the answer to the problem.